From the moment we first gazed at the stars, we've wondered, are we alone in this vast, mysterious universe? That simple question has echoed through the ages, whispered around campfires, painted on cave walls, and pondered by philosophers and scientists alike. The night sky, with its endless tapestry of twinkling lights, has always inspired both awe and curiosity in the human heart. This question is as much about our own identity as it is about science. When we look up, we're not just searching for distant neighbors, we're seeking to understand our own place in the cosmos. Are we a unique accident, or part of a grander story unfolding across the stars? The universe, with its billions of galaxies and stars, is almost unimaginably vast. Each tiny point of light could be a sun, with its own family of planets, perhaps even its own forms of life. The scale is so immense that it challenges our imagination, stretching the limits of what we can comprehend. Now we know Earth is just one planet orbiting an ordinary star in the Milky Way. Our solar system is but a tiny speck in a galaxy of hundreds of billions of stars, and our galaxy is just one among countless others scattered across the universe. This realization has transformed our understanding of our own significance. This realization is both humbling and thrilling. It suggests life could exist elsewhere. If the conditions that gave rise to life on Earth are not unique, then perhaps, somewhere out there, other beings are looking up at their own night sky, wondering the same things we do. The same elements that make up our bodies are found throughout the cosmos, forged in ancient stars. Every atom of carbon, oxygen, and iron in our bodies was created in the heart of a dying star, scattered across space, and eventually woven into new worlds and new life. In a very real sense, we are made of stardust. Our search for life has evolved from philosophy to science. We send probes to distant planets, use powerful telescopes to peer into the depths of space, and listen for faint signals from the stars. Each new technology brings us closer to answering the age-old question, are we alone? Each discovery, an ocean beneath the icy crust of a distant moon, a planet orbiting a faraway star, adds a new piece to the puzzle. These findings fuel our imagination and drive us to keep searching, to keep asking questions, and to keep exploring the unknown. The search for extraterrestrial life is, in many ways, a search for ourselves. It's a journey that challenges us to reflect on what it means to be alive, to be conscious, and to be part of a universe so much larger than ourselves. Even if we never find an answer, the pursuit itself expands our perspective and deepens our connection to the universe. It reminds us that we are explorers by nature, driven by curiosity and wonder, always reaching for the stars. It reminds us how precious and fragile our own world truly is. In searching the cosmos, we come to cherish our own blue planet even more, understanding that, at least for now, it is our only home, a tiny oasis of life in a vast, mysterious universe. Our solar system is more than just the 8 familiar planets. Beyond Neptune lies the Kuiper Belt, home to icy dwarf planets like Pluto and Eris. NASA's New Horizons revealed Pluto as a geologically active world, possibly with a subsurface ocean. The presence of water, even deep beneath ice, expands our idea of where life might exist. Dwarf planets are time capsules, preserving the building blocks of life, water, ice, and organic molecules. These bodies may have delivered essential ingredients to early Earth, seeding it for life. Studying them helps us understand both our origins and the potential for life elsewhere. The edge of our solar system reminds us, life could thrive in places we once thought impossible. Some of the most promising places to search for life are surprisingly close to home, right here in our own solar system. While the vastness of the universe tempts us to look far beyond, it's the worlds orbiting our own sun that may hold the first answers to the question, are we alone? Mars, the red planet, once had flowing rivers and lakes, and a much thicker atmosphere. Today, it's a cold desert, but it still holds tantalizing clues beneath its rusty surface. Ancient riverbeds, deltas, and minerals that could only have formed in the presence of water. These features hint at a time when Mars may have been a cradle for life. If life ever took hold on Mars, it may have retreated underground as the planet dried out. There, beneath layers of rock and ice, life could be shielded from harsh radiation and extreme cold, surviving in pockets of briny water or within protected caverns. That's why future missions to Mars are equipped with drills and advanced instruments designed to dig deep below the surface. Scientists hope to find biosignatures, chemical traces, or even dormant microbes that could prove life once existed or perhaps still does on the red planet. But Mars isn't the only intriguing world. Farther out, Jupiter's moon Europa is covered in a thick shell of ice, beneath which lies a vast, global ocean. This hidden sea contains more water than all of Earth's oceans combined, making Europa a prime candidate in the search for extraterrestrial life. Powerful tidal forces from Jupiter stretch and squeeze Europa, generating heat and possibly creating hydrothermal vents on its ocean floor. On Earth, such vents teem with life, thriving in complete darkness. If similar environments exist on Europa, they could provide the energy and chemistry needed for life to emerge. Saturn's moon Enceladus is another ocean world, and it's even more dramatic. Geysers erupt from its south pole, blasting plumes of water vapor and organic molecules into space, direct evidence of a salty, subsurface ocean. The Cassini spacecraft flew through these plumes, detecting water, salts, and complex organic compounds, the essential ingredients for life as we know it. These findings have transformed Enceladus from a frozen moon into a key target in the search for life. Together, these ocean worlds, Mars, Europa, and Enceladus, have shifted the search for life from pure speculation to a testable scientific quest. They offer real places where we can look for evidence using robotic explorers and one day, perhaps even human missions. Mars, Europa, and Enceladus represent our best chances to find life within our solar system. Each world is unique, yet all share the key ingredients, water, energy, and chemistry, that make life possible. Every new discovery, every sample returned, brings us closer to answering the age-old question: are we alone in the universe, or is life a common thread woven throughout the cosmos? The search for life beyond Earth is no longer just a dream, it's a scientific pursuit, unfolding right now, with each mission and every new world we explore. Space is harsh. High-energy cosmic radiation bombards worlds without thick atmospheres or magnetic fields. On Earth, our magnetic field and atmosphere shield us, allowing life to thrive. Mars, lacking these protections, is exposed. Any life there must hide deep underground. Some Earth bacteria, like Deinococcus radiodurans, survive extreme radiation with remarkable DNA repair. Perhaps alien life has evolved even greater resilience. The study of extremophiles shows us life's limits and hints at how it might survive elsewhere. Even the idea of life hitchhiking between planets, panspermia, depends on surviving this cosmic gauntlet. While we search for microbes, we also listen for intelligence, SETI's quest. Radio telescopes scan the sky for signals that stand out from cosmic noise. The waterhole frequency is a favorite, a quiet patch where water-based life might communicate. Despite decades of listening, we've found no conclusive signals, just tantalizing hints like the WOW signal. New telescopes like FAST and the Square Kilometer Array will expand our reach. We're also searching for techno-signatures, laser pulses, industrial pollution, or even alien megastructures. The search for intelligent life is a profound hope, that we're not alone in the cosmos. Even silence teaches us about our place in the universe. If we find life elsewhere, it will likely be microbial. On Earth, microbes dominated for billions of years before complex life evolved. Extremophiles thrive in boiling springs, deep-sea vents, and Antarctic ice, showing life's resilience. This broadens the range of worlds that could host life. Places once thought inhospitable may teem with microbes. If simple life arises easily, the universe could be filled with it. Finding even a single microbe elsewhere would revolutionize science. It would reveal whether life is a cosmic fluke or a natural outcome. Studying alien microbes could show us if life everywhere shares a common origin or arose independently. The smallest life forms may hold the universe's biggest secrets. For centuries, humanity gazed up at the night sky, believing our solar system's planets were the only ones in existence. The idea that other worlds might circle distant stars was the stuff of dreams and speculation, not science. But in just the past few decades, everything changed. Now we've discovered thousands of exoplanets, planets orbiting stars far beyond our own sun. Each new discovery has expanded our understanding of the universe and our place within it. Thanks to groundbreaking missions like Kepler and TESS, we now know that planets are not rare at all. In fact, they're everywhere, ranging from massive gas giants that dwarf Jupiter, to rocky worlds even smaller than Earth. Some are scorched by their stars, while others are frozen in darkness. Some of these exoplanets orbit two stars, creating double sunsets like those imagined in science fiction. Others drift alone, untethered to any star, wandering the galaxy in perpetual night. This exoplanet revolution has transformed our search for life. The question is no longer if life exists elsewhere, but where in this vast cosmic ocean it might be hiding. Every new planet discovered is a potential home for life. Scientists are now focusing their search on rocky, Earth-sized planets that orbit within the habitable zone, the region around a star where temperatures could allow liquid water to exist. Water is essential for life as we know it, making these worlds prime candidates in our search. The next frontier is to study the atmospheres of these distant worlds. By analyzing the light that passes through or reflects off their atmospheres, scientists can search for signs of life, like water vapor, methane, or oxygen, which could hint at biological activity. The James Webb Space Telescope is revolutionizing this search. With its powerful instruments, we can now taste the air of distant exoplanets, detecting the faintest traces of gases that might reveal the presence of life. If we find a mix of gases that shouldn't exist together, like oxygen and methane, it could be a sign that something alive is at work, reshaping the planet's atmosphere. With billions of planets scattered throughout our galaxy, the odds seem to favor the existence of life somewhere out there. Each new discovery brings us closer to answering one of humanity's oldest questions. We stand on the threshold of a new era, one where we may soon discover not just new worlds but perhaps, for the first time, evidence of life beyond Earth. Our Milky Way is just one of hundreds of billions of galaxies. Each galaxy is a cosmic laboratory with unique environments and histories. Some are violent, with supermassive black holes, others are tranquil but may lack the elements for life. Could life have started earlier in ancient galaxies, or do they lack the ingredients? The Hubble Deep Field shows us a universe teeming with possibilities. If life is common, distant galaxies could host countless civilizations. The universe is vast in both space and time. The story of life may be written across both. The search for alien life is also a search for a second Earth, a world like our own. Finding such a planet would confirm we're not unique but part of a cosmic family. The requirements are daunting: the right size, star, distance, climate, and more. The more we learn, the more we appreciate Earth's delicate balance. This quest is a mirror, reflecting our hopes and fears for the future. Even if we find an Earth twin, it would be unimaginably far away. There is no easy escape. We must cherish and protect our home. The search for life beyond Earth is as much about looking inward as outward. It challenges us to consider our purpose and our responsibility. In searching for others, we discover ourselves and the preciousness of